So in this video, I'll discuss addition reactions in alkenes. So yung factors that affect addition reactions, pati yung mechanism. So before that, I'll have to review you on how to synthesize alkenes depending on the elimination reagent or yung base. Okay? So if you have a sterically unhindered base like NaOH, okay, using heat, you have a Zaitsev product kapag ka nireact mo siya sa alkyl halide. Okay? So this alkyl halide will produce a more substituted alkene. Pero kapag hindered yung base mo, ibig sabihin malaki yung kanyang mga size or at least yung kanyang alkyl groups, malaki, masyado. Hindi siya masyado makakapasok dito sa hydrogen na to. Instead, ang atakihin niya ay yung less hindered na hydrogen or yung mas exposed na hydrogen para sa E2 reaction. So, ang nagiging mas dominant na product mo ay yung mga less substituted na alkenes. So, this alkene is a rearrangement product kapag E1 yung mechanism. But in this case, okay, yung E2 product yung mag-prevail because of the heat present. Okay? So let's analyze addition reactions reagent by reagent. So kapag gumamit tayo ng bromine or Br2, the formation of the cyclobromonium intermediate, okay, promotes the formation of the anti-product. So anong ibig sabihin ng anti? Ibig sabihin sa dihedral angle, 180 degrees ang na-form nila. So kapag ka-drawing mo yung Newman projection yan, okay, yung Br, so yung Br nandito, tapos yung Br sa likod ay anti. So this is 180 degrees. Okay? So for the HBr or the hydrohalogen, okay? So hindi naman masyadong selective to dun sa magiging product kasi hydrogen naman to, okay? So whatever hydrogen is present there, hindi naman siya magiging anti or syn, okay? Kapag syn, yung kanilang dihedral angle ay gauge, okay? So nasa 60 degrees ang kanilang dihedral angle. Okay? So, kapag naman syn, ganyan lang yung angle nila, 60 degrees. Okay? But in this case, dun sa first reaction, anti, 180 degrees. Okay? So, dito, hindi siya selective sa magiging stereochemistry ng product because of the hydrogen. So, wala namang masyadong impact ng hydrogen dyan. Also, for the addition reactions, okay, yung hydrogen, napupunta siya sa less substituted carbon because of the Markovnikov rule. Okay? So, na-discuss ko na yung Markovnikov rule in the previous videos. So, Markovnikov rule suggests that the formation of the more substituted carbocation is favored. Okay? So, kapag favored siya, yung more substituted alkyl halide yung mag-dominate or siya yung magiging major product ng reaction. So, dito, HBr, okay, promotes Markovnikov addition. So, this is a Markovnikov addition kasi ang napoproduce mo ay yung more substituted na alkyl halide. Kasi, hindi nag-a-add dito yung bromine. Okay? Dahil, kung dyan mag-a-add yung bromine, okay, dito yung magiging carbocation. Hindi yun stable. Okay? Yun yung ibig sabihin nun kapag doon nag-add yung bromine. Primary yung naging carbocation mo. Hindi stable ang primary carbocation compared sa secondary. Mas stable to. So, ang napoform niya ay secondary alkyl halide. Okay? However, the peroxide reacts to HBr, okay, to form the bromine radical. Ang nangyayari kapag may hydroxide na, so kapag halimbawa nilagyan natin to ng ROOR, okay, nagiging less substituted yung ating alkyl halide. Bakit? So, ang nangyayari kasi, ang na-form nyo muna ay yung bromine radical. At yung bromine radical yung unang nag-a-add dun sa alkene. Okay? So, in turn, yung alkene magpoproduce siya ng more substituted free radical, okay, carbon radical. So, the more carbon radical, actually, it follows the Markovnikov's rule. The more substituted, okay, carbocation or carbon radical or any more substituted intermediate, okay, siya yung dapat na mag-dominate sa process. Pero apparently, nagiging anti-Markovnikov siya. Okay? So, this is just apparent. Pero Markovnikov's rule pa rin naman yan. Okay? Ang nangyayari lang kapag sa peroxide effect, bromine radical yung una nag-a-add. Kapag wala kang peroxide, H plus yung una nag-a-add. Okay? So, both, okay, will add to the less substituted carbon para mag-form ka ng more substituted intermediate. Ang nangyayari lang, okay, nauuna yung hydrogen dito, so the more substituted carbocation will be attached to the Br, while the hydrogen, okay, here, will be attached to the more substituted carbon radical. Okay? So, kapag may peroxide, less substituted yung iyong alkyl halide. Kapag wala, more substituted yung alkyl halide. Or, Markovnikov's rule prevails kapag walang peroxide effect. Anti-Markovnikov naman yung product mo kapag may peroxide. Okay? So, as a summary of the Markovnikov's rule, kapag meron kang typical hydrohalogenation reaction, okay, mag-a-add muna si H+. Okay? Yan yung mechanism. Mag-add muna si H+, tapos magpo-form ka ng more stable carbocation. This is the Markovnikov intermediate. Okay? Intermediate. So, the Markovnikov intermediate can rearrange further kasi pwede tayo magkaroon ng hydride shift. Kasi this is a tertiary carbocation, this is a secondary carbocation. So, pwede tayo magkaroon ng rearrangement mechanism kapag ka may opportunity. So, we can form the Markovnikov product as well as the rearrangement product. However, kapag ka meron tayong peroxide, like hydrogen peroxide, okay, and other peroxides, yung bromine radical muna yung na-add. Okay? Ang nangyayari dyan, okay, nagkakaroon naman tayo ng more stable na carbon radical. Therefore, ang mangyayari kapag ka nag-add naman yung hydrogen radical dyan through free radical, okay, mechanism, kakaroon tayo ng apparent na non-Markovnikov or anti-Markovnikov na product. Okay? So, let's take a closer look at the carbocation rearrangement mechanisms. So, sinasabi lang nito na merong opportunity na mag-change yung iyong carbocation para mag-form siya ng mas stable na carbocation. Okay? So, meron tayong dalawang klase ng shift. Yung hydride, tsaka methyl. Marami pang klase ng shift. Meron pang phenyl shift, etc. So, i-discuss ko lang tong dalawang to. Okay? So, sa typical hydrohalogenation, kapag yung carbon na involved dun sa double bond ay katabi ng tertiary carbon, okay? This is a secondary carbon. Magpo-form tayo ng secondary carbon intermediate or carbocation intermediate because of the Markovnikov's rule, of course. Nandito yung hydrogen. Pwedeng mag-transfer yung hydrogen na to, okay, doon sa carbocation na yun para mag-form ka ng mas stable na carbocation. This is a 1,2 hydride shift. Okay? So, ito yung name niya, 1,2 hydride shift. Kapag naman, yung same carbon, okay, this is a secondary carbon na involved sa double bond, okay, may katabi siyang quaternary carbon, okay, possible na yung methyl group ng quaternary carbon na yun, lumipat doon sa secondary carbocation after the preliminary step or yung first step ng addition reaction. Magpo-form naman siya ng tertiary carbon pa din. So, ang tawag naman dito ay 1,2 methyl shift. So, kapag may enough opportunity for rearrangement reactions, pwede nating isulat yung product na may naging effect or naging product ng rearrangement. Okay? So, meron tayong mga rearrangement products based on the carbocations that are mentioned. Meron din naman tayong mga Markovnikov products. So, magkakaroon tayo ng kind of a mixture ng products dun sa reaction kapag may opportunity for rearrangement. Kaya usually sa synthesis, iniiwasan natin ang mga unimolecular mechanisms kasi nagkakaroon tayo ng mixture of products kasi nagkakaroon ng opportunity mag-rearrange yung iyong intermediate. Okay? So, the following are reactions that follow the same addition mechanism. Okay? So, titignan lang natin dito kung paano na-form yung product. So, first, halogenation. So, this is an anti-addition kasi because of the existence of the theorized bromonium intermediate. So, kapag may bromonium intermediate ka, yung Br- mo, okay, uma-attack siya sa opposite side. Kaya anti yung stereochemistry ng yung product. Okay? Sa hydrohalogenation naman na Markovnikov, syn addition daw. So, ibig sabihin, yung hydrogen mo tsaka yung bromine, they are at gauge position with respect to each other. So, ito yung bromine na nag-add. Ito naman yung hydrogen na nag-add dun sa unang step. Okay? So, ganyan yung syn addition. So, yung hydrohalogenation na anti-Markovnikov, baliktad naman. Less substituted yung iyong alkyl halide, tapos nandito yung hydrogen. Again, free radical yung mechanism nito, kaya naunang mag-add yung Br. Okay? Sa hydration reaction, ang unang aatakihin ay yung H+. So, yung nucleophile mo na a-attack dun sa carbocation after ay yung H2O. Siyempre, magpo-form ka ng intermediate na ganyan. Okay? Na plus. So, kukunin lang niya yung bond dun sa hydrogen. So, mare-regenerate mo yung H+, tapos magpo-form ka ng alcohol na product. Okay? This is syn addition din. Hydroboration oxidation reaction is the formation of the less substituted alcohol. So, yung hydration reaction, yung typical hydration or yung simple hydration reaction, more substituted alcohol yung napoproduce niya. Yung hydroboration oxidation, ang napoproduce niya ay yung less substituted alcohol. So, tandaan niyo yan, ha? So, sa less substituted na carbon, na-attach yung OH. Sa more substituted na carbon naman, na-attach yung OH dito sa hydration. Okay? So, now let's answer some problems. So, ang gagawin lang natin, magpipredict tayo ng addition products ng mga reactions na to. So, for number 1, madali lang kasi this is just a simple Markovnikov addition. So, susulat ko lang ulit yung skeletal structure. Okay? Tapos, nandito yung Br, sa more substituted carbon, the hydrogen is here. Syn addition siya, so that's hydrohalogenation. Okay? So, hydrohalogenation din to. So, ano kaya dito yung mass substituted na carbon? Okay? So, mas stable yung carbon na to kaysa dito because of the hyperconjugation, di ba? So, magkakaroon tayo ng ganitong product. Okay? So, that's the hydrohalogenation product for number 2. So, dito naman, meron tayong peroxide. So, dito sa less substituted carbon, mag-a-add yung bromine. So, magkakaroon tayo ng ganitong product. Okay? So, syn addition pa rin yan. Okay? So, finally, we have number 4. Okay? So, this is a simple hydration reaction. Again, kapag simple hydration, dito lang mapo-form yung OH natin. Doon mapupunta. Okay? Sulat natin yung product. Ganyan. So, nandito yung H. Okay? So, this is a special reaction. So, ang tawag dyan ay halohydrine formation. Okay? So, ano nangyayari dyan? Sulat natin yung mechanism. Ang una mag-a-add dyan ay yung PR. Okay? So, syempre dito yan. Okay? Sa less substituted carbon. So, may plus ka. Since H2O is more nucleophilic than Br minus, di ba? Periodic trends. Mas electronegative si Br minus kaysa kay water. So, water is more nucleophilic than Br. So, siya yung mag-a-add. Okay? So, kapag nag-add yung water, form ka ng intermediate. Actually, this is also an intermediate. Okay? Form ka ng oxygen yan. Okay? So, this is plus. So, kukunin niya lang yung bond. Okay? And then, mapo-form mo na yung product. So, the product is called a halohydrine. Meron siyang hydroxide, meron din siyang halogen. So, halohydrine. Okay? So, the addition is also Markovnikov kasi more substituted yung iyong carbocation. Okay? Now, let's check kung meron tayong mga possible rearrangement products based dun sa structure ng ating mga given substrates. So, for number 1, may katabing tertiary carbon, yung secondary carbon natin. So, possible na magkaroon tayo ng ganitong product. Okay? So, that is the hydride shift product. Okay? Nag-hydride shift yung tertiary hydrogen na ito. Okay? So, that's the possible product for number 1. So, sa number 2 naman, meron tayong quaternary carbon. Okay? Nakatabi nung ating secondary carbocation dun sa intermediate. So, possible na magkaroon tayo ng methyl shift naman na product or rearrangement due to methyl shift. So, nandito na yung iyong Br. Okay? So, nag-methyl shift na to, napunta na siya doon. Okay? So, next, since this is a free radical reaction, so the free radical reactions are usually very fast. So, rearrangements might not be very common. Okay? So, proceed tayo sa number 4. Yung ating secondary carbon here ay may katabing tertiary carbon right there. So, possible na magkaroon tayo ng rearrangement product na due to hydride shift. So, meron tayong OH na nandito. So, tertiary alcohols are possible in this situation. Okay? So, finally, sa number 5, possible na magkaroon tayo ng halohydrine, okay, due to the methyl shift caused by this methyl group kasi nasa quaternary carbon siya. Magpo-produce siya ng tertiary carbocation after the shift. So, we can have or possibly magkakaroon tayo ng ganitong halohydrine. So, nandito na yung OH, nandito yung methyl group, and nandito yung Br. Okay? So, for the rearrangement products, hindi mo sila necessarily kailangang ilagay palagi. Okay? Pag may opportunity lang for the rearrangement, tsaka lang siya nire-require ilagay. Okay? Usually, ang target talaga natin dito ay mga major products lang or the Markovnikov or the anti-Markovnikov products. Okay? So, sa next video natin, i-discuss ko na yung other reactions ng alkenes. Tapos, meron din ako dong sample problems. So, see you next video.